How to determine coordinates of a turning point. Today I'll be teaching you how to determine coordinates of a turning point of a parabola. Others call it quadratic function. The first thing I'm gonna do is to show all the equations of a parabola to you. I'll be teaching you how to determine coordinates of a turning point of a parabola when it's in the form of number 1, 2 and 3. Let's start with number 1. Given f of x is equals to x squared minus 2x minus 8. Determine coordinates of a turning point of f. We need to find x and y coordinate of a turning point of f. We always start with the x coordinate. To find the x coordinate of a turning point when you are given an equation like this, we use this formula. X is equals to negative b over 2a. Negative 2 is b, 1 is a on this equation. Let's substitute them. X is equals to minus negative 2 over 2 times 1. X is equals to 1. We found the x coordinate of a turning point. We're gonna use it to find the y coordinate. To find the y coordinate of a turning point, we'll need to substitute the x coordinate into f of x. Let's substitute. Therefore, y is equals to negative 9. Our TP, which is a turning point, has x coordinate of 1 and y coordinate of negative 9. We are done with equation number 1. Let's move to equation number 2. Things you need to know about this equation are: P help us to determine the x coordinate of a turning point, and Q help us to determine y coordinate of a turning point. Therefore, determine the x coordinate of a turning point with this equation. We gotta write x minus p is equals to 0, then x is equals to p. This means that p is the x coordinate of a turning point. We take q as it is to make it our y coordinate of a turning point. We don't have to subtract it with anything or from anything. Let's look at this example. Given f of x is equals to x minus 1 all squared minus 9. Determine the coordinates of a turning point of f. To get the x coordinate of a turning point, we're going to write x minus 1 is equals to 0, then transpose 1 to the other side, x is equals to 1. Then we conclude the turning point of f has x coordinate of 1 and a y coordinate of negative 9. You got to always remember that we take q as it is. Q is negative 9 on f of x, so we took it as it is. We are done with equation number 2. Let's move to equation number 3. Things you need to know about this equation are: x minus x1 help us to determine the first x-intercept of the quadratic function. Remember, quadratic function has 2 x-intercept, so x minus x1 will help us to determine the first x-intercept of the quadratic function, and x minus x2 will help us to determine the second x-intercept. I'm gonna break down everything for you on this equation. We are given f of x and we are required to determine the coordinates of the turning point of f. For us to determine the coordinates of the turning point of f, we'll first need to find the x-intercepts of f. We're gonna use x plus 2 to find the first x-intercept. We don't use it anyhow, we equate it with 0. To find x, we transpose 2 to other side, then x is equals to negative 2. Let's find the second x-intercept. X minus 4 is equals to 0, x is equals to 4. Remember, the question needs us to determine the coordinates of a turning point of f. We're gonna use this x coordinates of the x-intercept to find x coordinate of the turning point of f. What I need you to know this, please pay attention. The x coordinate of the turning point of a parabola is the midpoint of the x coordinates of the x-intercept of a parabola. So to find the x coordinate of a turning point of f, we're gonna add the x coordinates of the x-intercepts of f and divide them by 2. X is equals to 1. To find the y coordinate of the turning point, we're gonna just substitute the x coordinate into f of x. Let's substitute it. y is equals to negative 9. The turning point of f has the x-coordinate of 1 and the y-coordinate of negative 9. That's how you determine the coordinates of a turning point of a parabola. Thank you.